Since so many of you attempted the bonus question yesterday from the Unit 5 exam, I wanted to actually work through the bonus problem, especially because only one person got it correct. Shout out to Fish. So I wanted to talk you through this. This is an integral function problem that involves a little bit of algebra, but really is sort of conceptual about the way we define definite integrals and how we deal with area in different regions. So I think it's a pretty approachable one, but it's fairly crunchy. I think that's the tough part. Easy to understand, tough to actually execute a solution for. So our situation, as it says, the graph of a continuous function f of x is shown at right. It's a semicircle and two line segments. I'll also point out that the semicircle has radius 2. That's going to help us out a little bit here. From there, it says h of x is this integral function, and our problem then is that the graph has two zeros, one at 0 and one at x equals c greater than 0. The question is, what is that value of c? What's the non-zero 0 of this integral function h of x? So first of all, if we want to start to calculate that, it's a good thing to kind of point out. We want to say that h of c is going to be equal to 0, and what I'm going to do is I'm going to break this down using the definite integral properties first to kind of help us see where this is coming from, and then we'll attack from there. This isn't the fastest solution, this is the most conceptually grounded solution. So first I'm going to point out that this can be written as 3 different definite integrals. And again, c is going to be somewhere in here. I'll explain how I know where c is going to be. So first of all, it's going to be the integral from 0 up to 4 of f of x dx. And again, I'm choosing that because that's going to correspond to the semicircle. So this area, according to our picture, is half of the, let's see, we'll do it that way, 1/2 pi times 2 squared. And it is positive because the region is above the x-axis. Next, we're going to add to that the integral from 4 to 5 of f of x dx. Now this one's a little bit trickier, but like this little section is going to correspond to the tiny little triangle that we have right here. That triangle has a width of 3 and a height, or excuse me, a width of 1, pardon me, and a height of 3. So that area of the triangle, or that triangle's area, is going to be 1/2 base times height. But because it's below the x-axis, that region is going to be considered to have negative area. Now from here, like I can't just stop right there or say that our 0 has been found or anything, because obviously these two things aren't equal. Right now what we have is 2 pi, and then we have minus 3 over 2. 2 pi is 6.28. 3-ish. 3 over 2 is 1.5. Clearly we haven't equaled 0 yet. So what we have to do then is we need to figure out the other portion, which is going to add the integral from 5 to c of f of x dx. And that's effectively going to add a region that's somewhere over here. We don't know exactly where c is, but I'll just mark it somewhere about there. That seems about right. I mean, what the heck? That's going to be our region, and it's going to be the area of this trapezoid. And it's going to be a negative area of a trapezoid because the trapezoid's below the x-axis. So I'm just going to write this as minus the area of the trapezoid. Gosh, this thing's annoying. Minus the area of the trapezoid. So our real question here is, well, what is that area of the trapezoid represented as a function of c? The x value we're going to call our 0. And that's where the real challenge of this problem comes in. So I'm going to write this like so. So that's going to be minus and then this trapezoid. So I'm going to do some work over there in the trapezoid and then point out that, of course, our equation here is all equal to 0. So basically, once we've got that trapezoid in terms of c, we'll know what to solve for. So let's go attack the trapezoid. So I'm going to go off to the side here and start to look at that trapezoid's area. So first of all, a couple different dimensions. So first of all, let's just redraw this trapezoid so we can see it a little bit better. The better to know you with, my dear. So there's our trapezoid. So first of all, even though I labeled that 1, this is really x equals 5. So the width of the trapezoid is c minus 5. The height on the left is 3 for the same reasons we saw before. And now the height over here, this is where I think the trickiest part comes in. The height here is going to correspond to the y value we have at this point on the line. So in order to find this height, we're going to need to calculate the y value of this point right here, c comma something. So to find that, we first need to find the equation of the line. So that line has slope up 3 and over 4. I know it's over 4 because we're starting at 5 and ending at 9. So that line is going to be y equals, and we said up 3 over 4, and then it'll be x minus 9. And I'm doing y minus 0 here. I'm using the fact that this point over on the right side, so for point slope form, would give us 9 comma 0. So this is y minus 0. So there's the equation of our line. So the y value that's going to fall right here, based on that, will be 3/4 c minus 9. The problem with that, though, and we have to be really careful here, The problem with that, though, is that that number is negative. I mean, just think about it. C minus 9, because C is some number like underneath 9, is going to be negative. So we need to treat it as positive here. So we need to actually multiply by a negative sign. And I will admit that was one of the mistakes that I made when I first conceived of the problem. Having said all that, though, the area of a trapezoid, at least in this configuration, will be width over 2 times height 1 plus height 2. So the area of our trapezoid, oh, shoot, I made a mistake there. I apologize. This should be in terms of C. Like we're saying the value at C, so we'll plug it in. So the area as a function of C will be our width, which is C minus 5 over 2. I'll even put that in parentheses for the moment. And then height 1 plus height 2. And from here, we now have the area of our trapezoid for us to go plug it back in. So I'm going to go resubstitute it in. So pulling that out, I'll do this so that we remember that there was the star there. This is going to come out as C minus 5 over 2 times 3. And I'm going to go ahead and distribute this in because I do want to get the exact solution here. I know not all of you did. Fish was able to get it without doing the exact solution. 27 over 4. So there is our equation. It's a whole lot, and our job is to now solve for C. In a sense, I think the worst of it is sort of over, but also sort of not. We still have to do a bunch of algebra. So let's take care of as much of this as we possibly can. So the first move I want to do is basically just all the cosmetic work over here on that right side. I just want to take care of this whole thing. So a couple different moves that I'm going to do. The first thing, I'm going to add this to both sides. And then that way it'll just end up being positive on the other side. So if I do that, that's going to give me equals 0, or equals this. So basically there is my first move. I'm just going to make that move now to save us a little bit of computational time. Next, I'm going to distribute. And this is going to be a whole lot of a thing, but we'll just play with it for a second. We'll see what happens. We'll get 3 over 2 times C minus 5. We'll get minus 3/8 C times C minus 5. And then finally, we'll get plus 27 C minus 5 over 8. And all of that is equal to 2 pi minus 3 over 2. Now, my next move, I'm going to multiply everything by 8. I'm just going to fraction bust just because I think it'll clear things a little bit more. We'll get 16 pi minus 24 over 2, or minus 12, is going to be equal to 24 over 2, which is 12. And I'm going to distribute that in here. So 12c minus 60. On the next one, the 8 will go out. We'll have minus 3c squared. And then minus a negative 15c. I'm doing it a lot. I'm doing a lot of moves all at once. Hopefully this pays off okay. And then finally the 8s will divide out here. We'll get plus 27c minus 27 times 5. That's 270 divided by 2, which is minus 135. So there's our equation. Again, it's quadratic in C, which is good. We'll be able to solve this. It's just quadratic. So we got a bunch of movement to do here and a bunch of combining like terms. So I'm going to do a couple things. Again, this is just my personal approach here. I'm going to add 3c squared to the left side first. So that way we can move that over. Next, I'm going to look at the c terms. So we have 12c plus 15c is 27c, plus 27c is plus 54c. That's nice. Those have a GCF. That's actually going to help us a little bit. And then from there, we're again on the left side. We have minus 195. I'm going to add that over to the other side. So we'll have plus 195 minus 12. Ooh, is that 183? So plus 183 plus 16 pi. And all of that's now going to be equal to 0 because we moved it over to the other side. So we now have our quadratic. Now again, you can use the quadratic formula here, but I actually think that we're in better position than that. I'm going to use completing the square, just my personal choice. I'm going to factor out a 3. We'll have then c squared plus 18c. Let me just quickly make sure. I think I've done that right. Should have been plus 54 or minus 54. Hold on. We got 12c, 15c, 27c. That was plus 54. This should be minus 54. Apologies. So it doesn't change the number value, but it changes the scalar. So there we go. So I factored out the GCF. Then we're going to figure out what completes the square. But on the outside here, we do have plus 183 plus 16 pi. And then, of course, minus whatever we have to add in to complete the square. So figuring out what to complete the square, though, is actually pretty simple. Half of negative 18 is negative 9 squared. You get 81. So basically we have 3 times 81, which is going to be 243. And we're going to have 3 times that whole piece, which is 3 times c minus 9 squared. Over here, we've got 183 minus 243, which is going to be minus 60. So minus 60 plus 16 pi. And finally, all this is equal to 0. Now from here, I want to actually solve this. So I'm going to add the stuff to the other side and divide by 3. We'll end up with c minus 9 squared is equal to 60 minus 16 pi. That is positive, by the way. 16 pi is 48-ish, a little bit more than 48, maybe 50. All divided by 3. And then we're going to square root both sides. And we're going to get that c is equal to 9 plus or minus, and this whole square root thing. 60 minus 16 pi divided by 3. So now that gives us 2 possible answers. So it's worth asking ourselves, like, are both of these answers correct? So I'm going to paste it over here, and I'm going to go pull up Desmos, and let's actually investigate which... Yeah, just kidding. We don't need Desmos to do this. I already figured that out. Hold on. So let's go steal this picture really fast, and I'll explain why we know which answer is which. And then I'll actually tell you where the other answer comes from and what it means. And I copied the wrong thing. Let's just steal this. Okay. So basically, we're trying to find the c value, and we said already that the c value is somewhere over here. So basically, if we look at this, our answers, our possibilities are 9 plus square root of something, or 9 minus the square root of something. Since 9 is here, we need c to be less than 9. Therefore, the c value we're looking for is 9 minus the square root of 60 minus 16 pi, all divided by 3. This is one of, there's multiple exact versions you could go with, but there is the answer that we're looking for. If we're looking for the approximation that Kevin got, that is 7.198, or you could go, I think 7.199 is appropriate as well, depending on whether you're truncating or rounding. So there's our answer. Like, good stuff. We have our answer. Now, having said that, like, in addition to actually the answer, there is the question then of what in the heck are we getting when we get that 9 plus the square root of 60 minus 16 pi over 3? Like, what does that represent? And the answer is actually something sort of interesting. So let's pretend that that's our value right there. I mean, I guess technically c is a little bit closer over here. Let's see if that'll work. So let's go with that. There's our c value that we found. So the question to ask ourselves for this moment is, well, what would this other number be? Well, here's what happens. We have positive area right here. This was positive 2 pi area. This area down here is negative 2 pi of area. I mean, okay, technically we should write that it's positive 2 pi because it's below the x-axis, but you get what I'm saying. This is negative 2 pi. After that point, right here, at this moment, at c, we have 0 as the value of h. There's like a net area of 0. But then immediately we end up with a little tiny bit of negative area. And of course, our integral function stops at 9. That's all we have about f. But imagine for a second, as our computation does, that this line continues over further and further. What we are getting when we do that 9 plus the square root is we're actually getting the value right here. Like, this is, I don't know, it's not actually c. It's like, we'll call it c naught. We're getting c naught over here, which has the positive little area that cancels out this other little area. So again, what happens is our equation, which was based on the equation of the line, remember, right here, we actually use the equation of the line. The work that we're doing quadratically doesn't understand that the line stops. It thinks the line goes on forever. So we actually find what would be a third zero of this integral function if we were to continue forward, if our line continued rather than stopping at 9. So sort of interesting. Again, just sort of an interesting thing to think about. But the answer we were looking for was the one based on the information we have here, knowing that it ends at 9. There are the 2 answers. Congratulations to Fish for being the only person other than me to get it right. Also Yang Yi for working all the way through and getting to the answer after class finished. But yeah, good stuff. So thanks for watching. Hopefully that was informative, and great job everyone on your exam. It was a really nice performance this week. Thanks, bye.